Hi. In the previous video, we've covered a phase diagram for first order difference equation. Okay, now let's try to apply what we learned into the context of economic problem that we already dealt with. So, the cobweb model. Look, this is a first order difference equation that we actually dealt with when we were discussing the cobweb model, the market model. And look, I know that this is in a linear form, however, we can still very easily write this equation in the form that is basically giving us phase diagram. And look, let's say that we've already examined this equation, and it turns out that delta over beta is bigger than 0. Okay, so we know that in this case, we should expect that the time path of price is going to be both divergent and oscillatory. Let's notice here a very simple thing, right? This function we've got over here is our function that we use that we use with phase diagram. But look, of course, if I calculate derivative of this function with respect to price t, I'm going to get that f prime of pt is equal to negative delta over beta. And look, this brings us directly to what we covered previously. We have a situation in which we know that the line we will be dealing with is negatively sloped, right? And with this, we've got associated oscillations. Secondly, because absolute value is bigger than 0, so this derivative is lower than -1, we are also expecting divergence. Right? So let's try to now imagine that this situation is in practice. How it is in practice. So look, let's say that the government tries to stop this. Well, definitely a market where we have when the time path of price is divergent and oscillatory, it's very ineffective mechanism, right? So what government tries to do in our example is that government tries to impose a legal price ceiling. We will be denoting it as P hat. Okay, let's now place this on this axis. We're gonna have price in time t+1, and over here price in time t. Okay, we of course need 45 degrees line. Let's say function pt plus 1 as a function of finding the previous period. Okay, so of course over here we've got intertemporal equilibrium. So if price is at this point, it's constant, it's constant, so it means that both pt and pt plus 1 are equal to 1. However, let's one more time see what is going to happen here if the price is, let's just say, slightly below equilibrium level, right? If price is at P0, this period, then we can read from this line that the next period, the price is going to be P1. And then, if the price is P1, this period, then the next period, price is going to be P2. But if price, but if price in the period t plus 1 is P2, then here we can find price P2 on PT axis. Okay, and then again you will be able to see that the price for this price we will have very high price in period t plus 1. Okay, let's just make arrows to see what is happening in there here. Okay, first we got here and we see that with every turn we are getting further and further away from the equilibrium. Look, the next time the price would be even higher. So let's just say that our government wants to do something about it. And government, what it's trying to do is to try to impose a price ceiling. We will be denoting it as P hat. This is price ceiling. Okay, so this is a price above which price of this good cannot go. So what does it mean? It's like a price cap. It means that price cannot go higher. This is the maximum price. This is the maximum price at which companies can sell the product. Okay? So, look, what is going to happen now is that not only we're going to move from this difference equation, a situation we could just plot it over here so easily, to the case that we are in two different regimes. Sometimes price at times pt at time t plus 1 is simply equal to negative delta over beta pt plus alpha plus gamma over beta, right? However, if it is above some certain level, it is equal to P with hat. Okay, and now let's think about it. How would we see it? Look, basically this means that the highest price, let's just say we can have at time Pt plus 1 is the price set. However, this means This is really hard to draw, but I'm gonna try. The same is true for the time pt, right? But look, what it actually does is that it invalidates parts of this curve. Basically, the part of this curve that you see over here no longer works, and the same could be said over here. Now, basically, what happens is that the line that we are referring to is here. Okay, and now let's see what is going to happen. Look, let's denote it, let's just use the yellow color. Give me a second. Okay, and now, look. Again, price has gotten just a little bit below equilibrium level. So what happens? Well, we follow the blue lines, right? We see that with each next consecutive period, we see oscillation and we see divergence, and we are moving further and further away from equilibrium, right? But then we reach this level, and what do we see here? Price cannot be higher than P would have, right? So what happens? We are continuing over here, and each time we're going to, okay, this is it. Each time, and now each time we move from one period to another, we actually doing so-called unit cycle, which means that we go from the same point to the same point. So basically we get price that is constant, because over here we get price cap that is constant, because price over here and over here is actually the same. Okay, so the one last thing we need to do over here is to actually set down when one of these cases is prevalent. So look, let's just say that we've got some K, and this K is over here, right? This K tells us at which point our phase line gets kicked, right? So, what do we need to notice over here is that every time when PT is equal or higher than K, so we are somewhere over here, this works. However, if price is lower than K, then of course we need to use this fragment. I hope you can see it properly. This is PT higher than K, PT lower than K. Okay, so this is it about difference equations of first order since next week we're going to start dealing with second and higher order difference equations. Thank you for your attention. See you in the next video.